With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let us look at the question here, which says that CuSO4.5H2O is blue in color because, and we have been provided with 4 options and we need to choose the correct one. Now here we need to explain that why copper sulfate having water of crystallization having 5H2O in its crystal show blue color. Okay. Now to solve this question, first of all we need to understand that the color in compounds of transition metal is because of the incomplete N-1 d subshell, right? So if it is incomplete, it will have some unpaired electrons left, and due to that there will be dd transition that is happening, and due to that reason we see color, right? So let me just write down all of this. So the color in transition metal, okay, is due to transition metal ions, okay, or we can say metal compounds, right, is due to the incomplete N-1 d subshell, right? So if it is incomplete, it means it will have some unpaired electron left, okay? So it will have some unpaired electron. Okay. Now what will happen? See, the entire phenomena I'm just going to explain here. So here we have copper plus 2 ion, which has the electronic configuration of Ar18, 3d9 and 4s0, right? With 3d9 means it has one unpaired electron, right? One paired electron. How? If you just fill the electron diagram, if you just make an electron diagram and we try and fill all the electrons from d orbital, we'll have 1, 2, 3, 4, 5. So total of 9 we have to fill. So 5 with similar spin and 1, 2, 3 and 4 with different spin, right? So total of 9 we have, and 1 electron is left, and which is unpaired here. Now what happens in the presence of some strong ligand, okay? So in this case we have water. This orbital, this d orbital gets splitted into 2 energy levels, okay? So we have splitting, that is crystal field splitting, that is something that we called it according to CFT theory, that is crystal field splitting theory. Okay, let me just write it down. So according to crystal field splitting theory, okay, what happens? This d orbital in the presence of, right, any strong ligand, okay, what are ligands? So ligands are those which have a lone pair, right? So in the presence of strong ligands such as water, okay, there is a splitting of d orbital is something that we observe. Now d orbital here has total of 9 electrons. So 9 electrons will be filled something like this. So we have total of 6 here, and total of 3 we have for EG. So this is T2G and this is EG, right? EG, okay. Now here we can see that EG has 1 electron left. So sometimes what happens, that one of the electron from T2G level, which is the lower level, takes energy from visible radiation and gets promoted to, it gets excited and gets promoted to the higher energy level, that is EG, right? And just after some time it returns back to its original position, leaving or radiating the absorbed radiation in the form of visible spectrum, right? In the form of visible spectrum. And due to this reason only, we generally or often we see color coming out of transition metal ions or compounds, right? So in this case, in the case of copper, we see a blue color coming out of it, right? So this is the main reason why we are having a blue color, from coming out of CuSO4.5H2, right? So there are two reasons. The first one is that copper here has oxidation state of +2, which means it will have an unpaired electron left. The first reason this is. The second is that it will, in the presence of a strong ligand, which is water in this case, right? The d orbital of central metal atom of that is copper in this case will split into two energy levels, as we have seen here, right? And there will be electron getting promoted. There will be a phenomena where electron is getting promoted from a lower energy level to high energy level, right? Like this. And that electron, if returns back to its original position, will radiate the absorbed energy in the form of visible spectrum. And this is the reason why we have blue color in copper sulfate dot 5H2, right? So this is the crystal. This is the blue color crystal that we have. Okay. So this is something that we need to keep in our mind. Now, if this water of crystallization is not present in this particular crystal, then we don't see any color. We don't see a blue color coming out of it. Okay. So the main reason is this water of crystallization that it has. Okay. Now let us have a look at the options that we have. So the option is it contains water of crystallization. Yes, this is the correct reason. Now SO4 -2 ion absorbed red light, no. Cu+2 absorbed red light, no. Copper 2+ ion absorbs all color except no. This is also not the correct one, right? So only correct option that we have is it contains water of crystallization, which is acting as a strong ligand, and due to that there is a splitting that is happening and we are getting color eventually. So I hope you all understand. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.